Hello guys, welcome to Ramta Solutions and welcome to your lesson on grade 10 electric circuits. And to be precise, today we are looking at past papers. So the past paper that we are looking at here is from the Free State Province. It was written in November 2021. Okay, it was written in November 2021. So let's see. It says, the following circuit consists of 3 resistors, an ammeter, a voltmeter, and a switch. Study the circuit and answer the questions. Determine, or rather 5.1, define the term resistance. By the way, remember guys, this is 12 marks. When you say you are very slow in the question, you must have spent about 14 minutes. Okay, and if you were average, you spend exactly 12 minutes. Do not spend more than do not spend an excess of 2 minutes and more on a question. In excess, spend a maximum of 2 minutes. Okay, in excess, spend a maximum of 2 minutes. If you find yourself to be spending more than 2 minutes extra, please move to the next question so that you can come back to this question, because that means you're struggling to interpret the question. Okay. Now let's go. Now 5.1 says, define the term resistance. Remember we said resistance is, what was resistance if you recall? When we defined resistance, do you guys recall? We called resistance the measure of how hard it is to push electricity through a circuit element. Alright, let me give you that. A measure of how hard it is to push electricity through a circuit element. Right? Through a circuit element. Or you can simply call it opposition to the flow of charge. Okay, you can call it the opposition to the flow of charge. Okay, otherwise you can also use that formula R equals V over I, but in which R equals V over I, in which what is this? You can say resistance is the ratio of the potential difference across a resistor to the current, you can say to the current in that resistor. Okay, you can also say whichever you are comfortable with would be okay. I know some of you currently, when you look at these two definitions, you will go, or most of you in fact, you will go for the second It's okay, the shorter it is, the better, right? So yes, it is the opposition to the flow of charge. Now 5.2 says, calculate the total resistance of the circuit. Remember, when you begin your electric circuits calculations, always draw an outward arrow from the positive terminal. Here is the positive terminal, the long thin one. Okay, according to this circuit. So current flows in this direction, and then it meets a resistor here. Okay, it's in series. And then when it gets here, it gets divided. A part of it goes there, maybe let's call it I1, and a part of it goes there, maybe let's call it I2. So in other words, this is a parallel combination. And then boom, they meet again, and they are the same current that was here. It is now flowing here, right? Remember, the total current, this and this combined, will be the current that's measured by this guy. Okay, so now they say calculate the total resistance of the circuit. 1, pay attention that you have a parallel combination. So sort it out first. 1 over R sub P is equal to 1 over R sub 1 plus 1 over R sub 2. So what is this? This is 1 over 4 plus 1 over 5. I believe this will be something over 20. Let me see. 4 into 20 goes 5. and then 4. So this will be 9 over 20. All right, this will be 9 over 20. So 1 over R sub P. So you guys have calculators. Let's confirm. (0.25 plus 0.2), it's 9 over 20 indeed. Therefore, remember, we need to invert. R sub P is equal to 20 over 9. All right, so 1 divided by answer, it's 20 over 9 indeed. All right, so rounding this off, R sub P will be 2.22 ohms. Now, the question wanted us to find the total resistance. Therefore, total resistance is, let's see, it's this resistor here, right? It's this resistor here plus the RP, right? Because when you say RP, you're now connecting them in series. So it's 4 ohms plus R sub P, which is 4 plus 2.22, and this is 6.22 ohms. All right, this is 2.22 ohms. This is your total resistance. Okay, this is your total resistance. Now, let's see, 5.3, it says, if the battery can transfer a total of 120 joules of energy, that's, what is this, 1.3? So this is energy. I think they said 120, isn't it? It's 120 joules. It's 120 joules. Okay? To 10 coulomb of charge. 10 coulomb of charge. So charge is 10 coulomb. Now let me continue. If the battery can transfer a total of 120 joules of energy to 10 coulombs of charge, calculate the following. 5.3.1, the voltmeter reading. So this, we are looking at the total voltage or the potential difference supplied by the battery. What is that? Amp. Okay. Proceeding. 1.3.1. We know that potential difference is work done per unit charge. Right? It's work done per unit charge. What is that? It is 120 joules over 10 coulombs. What is that? This is 12. This is 12 volts. Right? This is 12 volts. Okay. This is 12 volts. Now, the next question, 5.3.2. I don't know why I said 1.3. Don't know. Let me sort it out. 5.3. 5.3. Okay. Now, 5.3.2 says the ammeter reading when 10 coulombs of charge passes through the ammeter in 5.18 seconds. Let's go. 5.3.2 ammeter reading. That means current flowing at the ammeter is unknown. Now, what is the time? The time, or let me call it delta T, is 5.18 seconds. Let me confirm. So yes, the ammeter reading when the 10 coulombs of charge passes through the ammeter in 5.18 seconds. Now, this, we know that current, what is current? We said that current is the amount of charge passing a fixed point in 1 second. So there was Q over delta T. What was Q? They said it's 10 coulombs. And what is the time? It's 5.18 seconds. Let's find our answer. 10 divided by 5.18. What is it? It is 1.93 amperes. Okay. It is 1.93 amperes. Okay. So this is you answering this question. And I guarantee you, this, everything that we have done, guarantees you 12 marks. Remember, do it in less than 12 minutes. And you are good to go. You will be able to finish your exam. So with that being said, Ours ends here. And bye-bye.